Okay, this problem here, we want to solve the equation. We want to solve for x. And right now I don't like that x is in my denominators. So what I'm going to do is multiply this entire equation by whatever my lowest common denominator is. I could find common denominators and multiply each fraction by something, but I'm just going to get rid of them all at once by multiplying all of this by an x squared. So I can multiply the 9 by the x squared, the 3 over x by x squared, the negative 2 over x squared by x squared, and the 0, of course, by x squared. So if I do that, what I'm going to come out with is a 9x squared plus 3x squared over x minus 2x squared over x squared, and that's equal to 0. Now this is convenient here because a whole bunch of these, or all of these fractions cancel. So I have an x squared over an x. That's going to be left with just an x to the first power. And over here I have an x squared over x squared. That cancels altogether. So I have remaining 9x squared plus 3x minus 2 equals 0. So here I have a quadratic set equal to 0. So we have to, let's try solving by factoring. So let's factor this into, I believe this will be a 3x and a 3x. And let's see, so this is going to be negative. So one of these will be positive. One will be negative, and it's going to end up to be a positive 3 when I add those middle terms. So let's say these two, let's check that. So this is a 6x, and this is a negative 3x, and together that does, in fact, make a positive 3x. So this is factored correctly. That's good. Let's get rid of this. Now that I have my factors, I can split this up. Split my factors, and let's solve. 3x plus 2 equals 0, and 3x minus 1 equals 0. So over here, I get a 3x equals negative 2, or x equals negative 2/3. Over here, I add 1, I get 3x equals 1, or x equals positive 1/3. So my solution set to this whole quadratic equation would be negative 2/3 and 1/3.